Hello, everyone. So we have a BmMT problem today. So this was on the 2024 number, I guess, 16. So this is a interesting problem. So we like it's not really that challenging, but it is kind of hard to see things. So which is well, let's see what we can do with this, right? So we have a triangle. So I'm going to start with any triangle to see something visually. And we are told, let's label this as ABC. So A, B, and C, right? And there is point D on side AB such that AD and BD are equal, which means that should be a midpoint. So let's say this is my point D. And then this guy and this guy is equal. And also BC and CD is also equal. Okay, so let's connect those as well. So DC, maybe having the same color might be useful to see. So these are equal. I'll make a bit bold. Okay, so these are equal to each other, even though it doesn't look like in my figure. So, and then there is E is placed on side AC such that angle ABC, so this angle is going to be twice of ADE. Okay, so E will be right here. So E will be on this segment. And then when you draw the ADE and ABC, the angle right here will be half of this one. But also we have something like AE is 4, CE is like 12. So which means E has to be close to A. So let's consider the point like A, somewhere like right here, right, E, because we are going to have that 4 units while the other is 12. So that would be just 4 while this is 12. Okay, so since we are talking about the angles, maybe I need to connect those D and E as well. So let's do that. And for this one, if I label the angle, so let's say this is alpha. So then twice of this will be angle B. But we kind of need to relate these. Like this guy is half of B, and having 1-to-2 ratio is usually helpful. And also, we have a midpoint, which we need to use as well. And if I kind of like split this angle into 2 equal pieces so I can get alpha and alpha, so that might be useful. So what I will do, I will draw a line from B in a way that will bisect the angle B, but I don't want to stop here. So I want to kind of continue with more, because the reason why I don't want to stop here, since D is midpoint, and when I extend this segment, we know that the angle right here will be alpha, and then this is also alpha because I just bisect the angle, and since this will be half of this one. So that guy and this guy is equal, which means DE and whatever that line I'm drawing is parallel. And since this is parallel to this one, and then this is midpoint, when we extend this all the way to here, so that means that segment is going to be also bisected by DE. So which is why I'm going to continue extending this line. So let's say that will hit AC at point, let's say K. So as I mentioned, like this is midpoint, and then this is equal to this angle. So DE and BK is parallel. So if these guys are parallel, and if this D is midpoint, so that means midpoint of AK is E as well. So which means this is 4, and this has to be 8, which is also nice because K is midpoint of AC, while BK is angle bisector. So this is angle bisector at the same time, that's midpoint, which has to be altitude as well. So which will force this to be 90 degrees. And we know DE and BK is parallel. So if this is 90, then this is also 90. So we have a lot of things going on, but at the same time, we are interested like finding BC, and with DC and BC is like even as equal, which we never used that yet. So what I'm gonna try to do now is like kind of relate those information that we have. So one of the things we can see, there is a triangle right here, like right triangle, AKB. When you have a triangle that is a right triangle, especially, like you can make a circle around it. Like you can see, if you draw the circle around this, since AB is going to be diameter, and then this is going to be one of the inscribed angle. So you can make a circle going through AB, and K. So, and then D will be the center of the circle. So this is a radius, this is radius, and D to K is also going to be radius. So you can go with that. But there is also a name for this. Like when you have a triangle, if you drop like a segment from the right angle to the midpoint of the hypotenuse, that segment you draw is also equal to other two pieces. So I think it's called Thales' theorem. So that should be equal to AD and BD. So these three are equal. But how this is going to be useful? It is good because I have these three are equal, but at the same time, we know D was midpoint and then K was midpoint of AC. So which means DK has to be parallel to BC as well. So let me make that visible. So why this is midpoint? Because, why this is parallel? So because D is midpoint, K is midpoint. So the ADK and ABC are similar by side angle side, because AD and AB is 1 to 2, AK and AC is also 1 to 2. Angle A is a common angle in those two triangles, so that's why they are similar, right? So then we can just say the DK to BC is also 1 to 2. And let's say this is X unit, and this is X unit, so that means DK is also X unit, so BC will be 2X unit. And that's the same as DC, so that is also 2X unit. Okay, so now we have a lot, but we do not have what we want, right? So we want this 2X, but when we look at our figure, we see that like ADE is a right triangle, and DAC is a right triangle, and then they have the same like leg, which is DE. If I use the Pythagorean twice and then make this H squared equal to each other, so then I will get this H squared plus 4 squared is equal to X squared. And in the DEC, we have H squared plus 4 plus like 8, which is 12. So 12 squared is equal to DC squared, which is 2X squared. So I'm just writing this, but like most people should skip these two. Like we just need to say X squared minus 4 squared, because when you make the H squared is equal, so there's gonna be like X squared minus 4 squared, and then 2X squared minus 12 squared will be equal to the same thing. So from here, so you can say X squared minus 16 is equal to 4 squared minus 144. So this is the first thing I would write without really doing these two. But if you kind of don't see it, you can always write the Pythag and go from there. But when you subtract, this is what you get, or when you subtract H squared under the equation, that's what you get, right? So if I simplify this, that should be 3X squared equals 128. And the X squared will be 128 over 3. So X will be 128 over 3 under square root. And this is going to be 64 times 2, which is 8 root 2 divided by root 3. And we like to get BC, which is 2X. So if you double this number, so you got 16 root 2 over root 3. But we cannot live that way, so we need to multiply this by root 3. So that should be 16 root 6 over 3. And that is our answer. So it wasn't really challenging, but at the same time, like it wasn't really immediately obvious. So I hope that was helpful. I'll see you in the next video.